What is the sum of the following series? We have the summation of ln of 1 minus 1 over n squared. What are we going to do? We're going to apply algebra so we can recognize telescoping pattern. First of all, 1 minus 1 over n squared can be written as n squared minus 1 divided by n squared, which is n minus 1, times n plus 1 over n squared. So this series can be written as the summation of the ln of n minus 1 times n plus 1 divided by n squared, n start from 2, goes to infinity. From the properties of ln, if you have ln of a divided by b, it's ln of a minus ln of b. And if you have ln of a times b, this is ln of a plus ln of b. Also, ln of u to power n can be written as n times ln of u. So far, we have something on the numerator, something on the denominator. So the series can be written as ln of n minus 1 times n plus 1 minus ln of n squared. Your n starts from 2, goes to infinity, which in turn can be written as the summation of ln of n minus 1 plus ln of n plus 1 minus 2 times ln of n starts from 2, goes to infinity. So this is what we did. We took the multiplication and write it as the summation. And here I took the exponent and write it in front of the ln. This guy also can be written as the summation of ln of n minus 1 plus ln of n plus 1 minus, you have 2 ln of n, which is minus ln of n minus ln of n. Why not? Now our goal is to combine these together. What I'm going to do, I'm going to take these two and write it as a division. And also between these two, I'm going to write it as a division, but I'm going to factor out negative sign as well. Take a look. This can be written as the summation of ln of n plus 1 divided by n. And let me copy down the rest of it. Plus ln of n minus 1 minus ln of n. Between these two, I'm going to factor out the negative sign. So this guy becomes the summation of ln of n plus 1 divided by n minus ln of n minus ln of n minus 1. N starts from 2, goes to infinity. So you have the summation of ln of n plus 1 divided by n minus the ln of n divided by n minus 1. N starts from 2, goes to infinity. I write it this way because I can recognize the pattern. Now, expand the series and find the partial sum. So S sub k is equal to the summation. K starts from 2 and stops at n, right? Or you can write n starts at 2, stops at k. N starts at 2, stops at k. Of ln of n plus 1 divided by n minus ln of n over n minus 1. So let us begin. When n is equal to 2, what do we have? We have ln of 3 divided by 2 minus ln of 2 over 1. When n is equal to 3, you have ln of 4 divided by 3 minus ln of 3 divided by 2. When n is equal to 4, you have ln of 5 divided by 4 minus ln of 4 divided by 3. When n is equal to 5, for example, you have ln of 6 divided by 5 minus ln of 4 divided by 3, plus the rest of the terms. You can continue this process. You get ln of k plus 1 divided by k minus ln of k divided by k minus 1. So if you see this, now stop and take a look at this. This is your s sub k. This is the partial sum. You can cancel out some of these terms. Which terms? Take a look. Negative ln of 3 halves, ln of 3 halves. Ln of 4 thirds, negative ln of 4 thirds. And this should be 5 over 4. Let me fix this. And negative ln of 5 over 4, ln of 5 over 4, and so on. This term and the term before it, they get canceled out as well. So what's happening here? Your s sub k is equal to negative ln of 2 plus ln of k plus 1 over k. If you take the limit of the partial sum as k goes to infinity, take the limit of partial sum as k goes to infinity, what do you have? You have limit of negative ln of 2 plus ln of k plus 1 over k as k goes to infinity. But this guy is just a constant, all right? You're going to copy this guy down. You have negative ln of 2 plus limit of ln of k plus 1 over k as k goes to infinity. But this guy is equal to negative ln of 2 plus ln of limit of k plus 1 over k as k goes to infinity. This is negative ln of 2 plus ln of limit here is equal to 1, but ln of 1 is equal to 0. So you end up with negative ln of 2. What's the meaning of that? It means that our series approaches to negative ln of 2. So let us recap what we did. We are finding the sum of the following series. I'm going to apply the method of telescoping pattern, telescoping series. So I did a little bit of algebra. I broke this guy down into smaller pieces using the properties of ln. I have the ln of n plus 1 divided by n minus ln of n divided by n minus 1. It helps me to recognize this pattern and get rid of some of the unnecessary terms in the middle. When you're forming the partial sum, plug in different values for your n, you see that you can get rid of the opposite terms. When you can get rid of the opposite terms, you end up with two terms, negative ln of 2 and ln of k plus 1 divided by k. Now take the limit of the partial sum as k goes to infinity. The limit of s sub k, k goes to infinity, is the limit of negative ln of 2 plus the limit of ln of k plus 1 divided by k. But as you saw, this limit is just 0. The limit is 1, so the limit of ln is just 0, and you end up with negative ln of 2. So it means that our series approaches to negative ln of 2.